Okay, so this is just a continuation of 6.2. So now we're going to do tangent of theta. If I can do full screen and then get my pen. We're going to do tangent of theta is the square root of 3. So again, we have this triangle. We know tangent is opposite over adjacent. So we would have the opposite, which is the square root of 3, over the adjacent, which is 1. So again, when we do Pythagorean theorem, we'd have the square root of 3 squared plus 1 squared equals the hypotenuse squared. So square root of 3 squared is just 3, plus 1 squared is 1. So we would get h squared equals 4, which means our hypotenuse is going to be 2. So now we can go ahead and we can do our 6 trig functions. So we'd have sine, cosine, tangent. Cosecant, secant, and cotangent. So sine opposite over hypotenuse would be the square root of 3 over 2. Cosine adjacent over hypotenuse, which is just 1 over 2. And then we know that our tangent is the square root of 3. Then when we go ahead and do our cosecant, we'd have the 2 over the square root of 3, which we know is 2 times the square root of 3 over 3. 2. And then 1 over the square root of 3, which is just the square root of 3 over 3. Now you go ahead and we have cosecant of theta. You go ahead and make your triangle for that and then put your 6 trig ratios. Okay, so on this one we're doing cosecant of theta equals 13 over 12. We know cosecant is the reciprocal of sine, so we're going to have hypotenuse over opposite. Then we have to go ahead and figure out what our adjacent side is. When we do our Pythagorean theorem, we end up with the adjacent side of 5. So we end up with sine of 12 over 13, cosine 5 over 13, tangent 12 over 5. Cosecant, which was given to us, is 13 over 12. Secant is 13 over 5, and then cotangent is 5 over 12. Now we're going to start evaluating these expressions without using a calculator. So if we look at our first one, we have sine of 30, cosecant of 30. So we know that we can do this a few different ways. We know that cosecant is the reciprocal of sine. So we can say, well, we have sine over 30, which is the same thing as 1 over sine over 30. So those are going to reduce down and it's going to give us 1. Also, we could think of our unit circle. If we have the square root of 30 and then 30, we know sine of a 30 degrees is 1/2. So cosecant at that 30 degrees is just going to be that reciprocal. So again, 2 over 1. So now these things will reduce and it will give us 1 just the same. So regardless, we get 1 as our answer. When we look at our next one, we have sine of 60 degrees squared plus cosine of 60 degrees squared. So again, if we go back to thinking about our unit circle, we know that sine of a 60-degree angle is the square root of 3 over 2. We know that cosine of a 60 is 1/2. And again, you have to just know how I got that. So square root of 3 squared is just 3. 2 squared is 4. 1 squared is 1. 2 squared is 4. So we end up with 4 over 4, which is just 1. Now the next ones are in radians. So you have to make sure that you can go again and realize what in radians these things are going to be. That wasn't what I was trying to do. So you go ahead and you work on this one, and then I'll come back and I will show you the solutions to this. Okay, Okay, so on this one, again, you have to realize that sine of pi over 3 is the same thing as a 60-degree angle. So sine is square root of 3 over 2. Cosine, 45-degree angle, is square root of 2 over 2. Sine of pi over 4, again, 45-degree angle, is square root of 2 over 2. And then cosine of that 60-degree angle is 1/2. Then we can go ahead and multiply, and we'd have the square root of 6 over 4 minus the square root of 2 over 4 squared. We can't actually combine these, but we can square them. So whenever you square and simplify, you end up with 8 minus 4 times the square root of 3, and then when you square 4, you get 16. We can go ahead and we can take 4 out of all of that, and that's how we get our 2 minus the square root of 3 over 4. So now we're going to solve this right triangle, which just means make sure that you give me all of the angles and all of the sides. So the first thing that we can do, we can go ahead and find that other angle. We know that the angles inside of a triangle have to add up to be 180. So if this is 75 and this is 90, this one has to be 15 degrees. So then going off the angle that they gave us, we have opposites, but we don't have the hypotenuse. So we could go ahead and we can say sine of 75 has to equal the opposite, which is 100, over the hypotenuse. We're going to have to multiply by the hypotenuse and divide by sine. So we would get 100 divided by sine of 75. So in your calculator, you just put 100 divided by, and then sine of 75. And you would get 103.53. Now when you go to figure out this other side, you still want to go ahead and just use the information they gave you, just in case this is wrong. Plus this is rounded, so it's just an approximation. We want to go ahead and use what we know to be exact. So again, we have opposite, we need adjacent. So we know that that would then be tangent. So tangent of 75 equals 100 over the adjacent. So the adjacent is going to equal 100 divided by our tangent of 75. So when you put that into your calculator, you end up with 26.79. Now you go ahead and work on the next one, and I'll come back with the solutions. Okay, so when we go to complete this one, we have that 68 degrees. So the first thing that we can do is our sine of 68 equals our opposite over 1,000. I went ahead and put it as x so it didn't look like a 0. So then we end up, when we do sine of 68 times 1,000 to get x by itself, you get 927.18. Then we know cosine is adjacent over hypotenuse, so we're going to have a over 1,000. And again, you do cosine of 68 times 1,000 and you get 374.61. Also, we know that 90 plus 68 gives us 158, so this angle has to be 22 degrees. So if you haven't already read through this, you'll want to make sure that you go ahead and do so. But we have this plane that's flying by the St. Louis Arch. We know that the plane's at an elevation of 35,000 feet, and that our angle of depression at the point on the ground below the arch is 22 degrees. We want to figure out the distance between the plane and the arch. So we're trying to figure out this hypotenuse. So we have opposite over hypotenuse, which is sine. So we would have sine of 22 equals 35,000 divided by h. So those are just going to switch places. So 35,000 divided by 22, sine of 22, sorry, which gives us approximately 93,431 feet. So our hypotenuse, 93,431 feet. Then they want to know the distance between a point on the ground directly below the plane and the arch. So they're wanting to know this adjacent side. Again, we want to use what we already have that we didn't figure out on our own. So we'd have opposite over adjacent, which we know to be tangent. So tangent of a 22 is going to equal that 35,000 over adjacent. So these again are just going to switch places, because we're going to multiply both sides by a and divide it by tangent of 22. And when we do that, we get approximately 86,628 feet. So 86,628 feet. Okay. So you go ahead and you look at the next one and try and work that out, and then I will come back and I will show you my solution for it. So on this one, we know that the top of the lighthouse is 200 feet. The angle of depression is 23 degrees, and we want to figure out the distance between the lighthouse and the ship. So again, that's tangent because we have opposite and we're trying to figure out adjacent. So tangent of 23 equals 200 over A. When you multiply by A and divide by tangent of 23, you end up with 200 divided by tangent of 23, which is approximately 471 feet. Now again, you go ahead and you read this next one, and then I'll come back with how I worked out the solution. Okay, so as we go to do this one, now we don't know what the angle is, but we know that we have the adjacent and the hypotenuse. That means that we're going to use cosine. So we have cosine of 6 over 20, which is the cosine of 3/10. Now when you want to find the angle, you have to actually use your inverse button on your calculator. So you would hit cosine inverse, and then it'll open the parentheses and you put 0.3, and that'll give you approximately 72.54 degrees. So that's our angle of elevation. Then we have to figure out this other side, so that's just Pythagorean theorem. We'd have a squared plus 6 squared equals 20 squared. So when we subtract 36 from 400, we get 364. And when we take the square root of both sides, we end up with 19. Here is your assignment that you're going to start working on. If you have any questions about any of this, feel free to ask tomorrow.